All right, so today, October 29th, we're going to be able to determine whether a function is a function, as well as define its domain and range. So we have a good amount of information to get through today, so let's just get started. Usually I skip these, but I think for today, this is a good one to have. So these are some examples. We're going to focus more on these. Well, these. So we have x and y, independent and dependent, domain and range, input and output. All right, and I feel like Dixie and Dory is an acronym that I should know. I will get back to you on that on a later video. But so we're going to know that x and y's go together, independent and dependent go together, domain and range go together, input and output go together. So these are going to be our big four that we're going to focus on. All right, so today, what we want to remember is that our domain is going to be our x values, and our range is going to be our y values. So a big thing we always need to remember is what a coordinate pair is. And that is going to be x comma y. So I'm going to put an x above all of my x values. So when I want to find out what my domain is, the domain is just going to be a list of all of my x values. So I'll have 0, 2, 4, and 6. And I'm going to put a y over all of my y values. Remember, range is going to be all of my y values. So I'll have 3, a 9, a 15, and a 21. Now, sometimes they might not always be in order like this. I would suggest putting them in order from least to greatest. I think it's just better to look at. Plus, that's the way it's going to look like on a test. Okay, so again, domain, x values, range, y values. Domain, x, range, y. All right, so again, we have domain and a range. And we need to state the domain and the range of the function. So the domain of the function is going to be all of these x values, right? And the range of the function is going to be all of these y values. So I'm going to start with domain. Now I have 12, 14, 16, and 18. All right, when I look at range, I will have, look, this is where I'm talking about, sometimes it won't necessarily be in order. So you can write out 4, 2, 0, -2, and that's going to be correct. But on a test, you'll probably see it as -2, 0, 2, 4. But that's just me being a little nitpicky. As long as you get all of your y values, right? So you have your 4, 2, 0, -2. As long as you have all of your y values inside of your range. Remember, domain is x values, range is y values. So we've been able to do it from coordinate points. We've been able to do it from a table. All right, these are coordinate points. This is going to be from a table. Now we need to be able to do this from a graph. All right, so again, we're just going to look at our x and y values. So because I've been doing this, x is domain, y is range. All right, so I know that my domain is going to be my x-axis. All right, so from my x-axis, I'm going to draw a line up to every point. Right, so I'm going to draw a line from every point down to my x-axis. How about that? And then I'm going to circle that number. All right, draw that line there, circle that number. Draw a line up here, circle this number. This is on your x-axis, so I'm just going to circle that number. Draw a line down, circle that number. Draw a line up and circle the 5. So my domain is going to be all of those numbers that I circled. All of these numbers are on the x-axis. Right? We can see that all of these numbers touch the x-axis. I drew the lines from each point to figure out which number on the x-axis it was going to be in my domain. So my domain is going to be -5. So I'm going to mark it off. Next one's going to be -4. You can't really see it with the dot there, but that's fine. I have my 0. I have my 1. I have my 3. And I have my 5. And that's going to be my domain. So to do range, I'm going to erase all of this. And now I'm going to focus on my y-axis. So I'm going to draw a line from each point to my y-axis, and I'm going to circle the number. Well, that number is already circled, so it's fine. Here's my 0. So that comes here, it's -1. This one comes over here, -3. And this one's on the y-axis at -5. So here my range, remember I like to go from least to greatest. So that would be -5, -3. Check them off as we go. -1, 0, check them off as we go. And then 4. Now I realize that I have 2 points going to 4, but we do not have to write 4 twice. We can just write it one time and that is good to go. So again, our domain is going to be our x values and our range is going to be our y values. All right, so now we're going to talk about what is the range in the function below when the domain is 1/4. Okay, so we have a function. And we know that our x value, our domain, right, because we know that domain is x, and we have our x value right here is going to be 1/4. So one way you can do this is you can simply put in a 1/4 for everywhere that you see x. Right, add 2 to that. So you will have y equals, let's see, 8 times 1/4, or 8 divided by 4 is 2. Bring down what we don't use. And y is going to equal 4. So our range in this case, remember range is y. We have our y here is going to be 4. So all we had to do here was take this 1/4, plug it right into this x, and it gave us our answer. Now you could also do this in Desmos the same way that we did when we were doing solving equations, right? You could put in y equals 8x plus 2, then put x equals, and put your 1/4. I'll do that on the last problem. All right, so what is the range of the function below when the domain is -2, 1, and 12? All right, so here we have 3 different numbers, but again, they're still just our x for domain and our y for range. So they give us our x, so we're going to plug these in to our x. Everywhere we see an x, we're going to plug these in. This is telling us what our x value is. This is basically saying x equals -2, x equals 1, x equals 12. All right, so I have y equals -6. I'm going to leave a space. That's where my variable is. That's where I'm going to have to plug in my x value. I'm going to say -1. Excuse me. And I'm going to put in my -2. So you'll see that y equals -6 times -2 is going to be a +12 minus 1. That was 1. Yep. And 12 minus 1 will give you 11. So our y value will just be 11. All right, again, I'm going to go y equals -6 because that comes from our linear function. And I'm leaving a space. That's where I'm going to put this 1 in. So I've already done -2. This is where I'm going to put this 1 in. And you'll see that I get y equals -6 times 1, where 1 is the multiplicative identity. So that's going to be -6 minus 1. -6 minus 1 will give you a -7. And that's what your y, that's what your range will be for y. And again, for my last one, I put -6. Don't forget to leave a space. That's where your variable is. That's where x is. And I'm going to plug in my 12. And I'm going to get y equals, what is -6 times 12 is 60, -72. I will subtract 1. -72 minus 1 will be -73. And that -73 is going to be my range, my y value. Remember, y is range. Right, so these are going to be your range values. All right, so what is the greatest? Oh, this is a tricky one. What is the greatest value in the range of the function y equals -1/4 times x plus 5 when the domain is -4, 0, 8? So we have to read the question here. All right, so I wanted to make sure I read that question correctly. All right, so first of all, we're going to go ahead and plug all of these. Remember, these are our domain. So we're going to plug these in for our x, and what it'll give us is our y. And the question is, what is the greatest value in the range? All right, so just to kind of show you on Desmos, well, we know that the function is y equals -1 divided by 4x plus 5. So I'm going to go x equals. Well, I know that I need to put in a -4, a 0, and an 8. So put in a -4, and you'll see that I get a 6 for my range. All right, so now I need to put in a 0, and you'll see that I get a 5. And I'm going to put in an 8. And if I had to guess, I would say I'm probably going to get a 3. And I do. I get a 3. That's how you do it on Desmos. We go over this in class. I don't want to spend a lot of time on this, on Desmos here. All right. So these would be our range values. So it says, what is the greatest value in the range? Well, this is our range, right? These values are our range. So we just have to figure out which one's our greatest. And 6 is greater than 5 and 3, so C would be our answer. All right, so this is the third topic of today. I guess really the second. No, it's the third. So is this a function? So real quick, I want to talk right here. Is it a function? All right, all you have to remember for this is if you have a duplicate, excuse me, x value, it is not a function. So you cannot have two x values that equal the same number. That's what this is saying. So is it a function? If it has a duplicate x value, it is not a function. So here, look. I'm going to cross out all the y values because I don't care about any of them. They do me no good when is this a function? With is this a function? So is the relation below a function? So let's see, I have a 3, a 1, a -3, and a 7. So are any of these the same? Do I have any other 3s? No. So this one's good. Do I have any other 1s? No. Do I have any other -3s or 7s? No. So this is a function. All right, this one, you guys should like this. This will be pretty easy. So let's get rid of the y's here again. Remember, we are not worried about y's when the question is the relation a function? Get rid of the y's. See, so I have 1, 1. Do I have another 1? 2, 3, 4, 5? No. So 1's good. I have a 2, 3, 4, 5. Just 1, 2, good. 3, 4, 5, good. 4, 1, 4, 1, 5. So this is a function. All right, is the relation below a function? Is it? Well, I can tell you right away. I don't care about these y values. So let's see, I have an 8, 2, and an 8 up. Right here you can see it. I have 2 8s. This is not a function. Not a function. No. Right, because I have 2 of the same x value. I have duplicates in the x column. I have 2 of the same x value. Cannot be a function. All right, is this relation below a function? Let's see. Get rid of the y's. Remember, we do not care. But before I get rid of them, look, all the y's are the same. Remember, the y's don't matter. You can have all of the y's be the same. That just means that it's a horizontal line. Right? And I can show you. I'll show you in a little while. I'll show you after this. So I have a 2. Do I have any other 2s? 6, 10, 14, 18. Nope. Make sure I switch my color up. 6, 1, 6, 1, 10, 1, 14, 1, 18, and 122. This is a function. And let me just quickly graph this for you. Right, so remember these are all points, right? So we have like 2, 9. We have 6, 9. Remember our x value and then our y. We have 10, 9, and so forth. So if I was just going to loosely graph this, and let's just say I have this is 9, right? We know that this is 0. I'm going to have 2. I'm going to have 6. Oops, sorry. Crazy. I'm going to have 2. I'm going to have 6. I'm going to have 10. I'm going to have 14. I'm going to have 18. And I'm going to have 22. So if I come over here, go to 2, 9, my point's going to be right here. 6, 9 will be here. 10, 9, 14, 9. Notice everything is staying on 9. And what you'll see is that I do, in fact, have a straight horizontal line. Bonus question is what type of slope is this? And if you guessed 0 slope, you would be correct. Remember what slope dude says. All right, so is the relation below a function? Well, remember, we are not worried about where these numbers are on the y, right? So we don't have to do like we did up here. Remember, we had to do this twice. We had to do 1 for the x, right? We had to do 1 for the x and draw all the lines down. And then circle the numbers. Well, for this, we don't even have to worry about that. We are only worried about the x. So we're not going to worry about the y. So I'm going to have, let's see here, comes down to, sorry, hold on. So I'm going to, my x-axis, and I'm going to draw a line. I'm going to go through the point all the way down. I'm just going to keep going. All right, you can see this line only hits 1 point. This line only hits 1 point. This vertical line only hits 1 point. This vertical line hits 2 points. It hits this point and this point. Well, what that's telling us is that there are 2 x values in this function. Okay, and what these points are, it looks like -4 and 4, and this one is -4 and -1. Well, our issue is with this -4 both being for x, because remember we have x and y, and we have x and y, and we only can have one. We cannot have duplicates of x values. Right, so this would not be a function. This is also known as the vertical line test. You guys will use the vertical line test well into high school and some of college. So that's a good one to remember. So just remember, is it a function? Duplicate x values is not a function. And then the vertical line test. If you can draw a vertical line and it touches a part of the function more than once, it is not, in fact, a function. All right, well, I hope that was helpful. If you have any questions, hit me up during Raider Prep. Or send me a message on Schoology. Don't forget we have a test next week. I guess that's pretty much it. All right, have a good one. Thanks, guys.